All right, so one of you after last class caught this immediately, and one of you a little bit later came up to me and told me about it. So last class we were starting on our second game, something that could be a bit more interesting, and it was this word scramble game where we open up this dictionary, we read all of the words into a big list, and for testing we actually filtered out any of the words whose length wasn't 4, and then we pick a random word, shuffle its letters, show them to the user, and then the user guesses or tries to make a word out of those letters, and then we check if the user guessed, made a correct word. So, and the way we did that was, so this is the user's guess, it's in a variable called guess, and we checked if that guess is in the list of words we have. Does anybody see the problem with that? Okay, well let's test it and see. So, Python, word game. Okay, make these letters into a word. Hall. All right, that looks good. So let's try a wrong answer. Okay, that seems to be doing the right thing. How about this? Right or wrong? It's in the dictionary. It's in the dictionary, but it has nothing to do with the letters that were shown to us. And so, as is usually the case, the program is doing exactly what we told it to do, not what we meant for it to do. Right? We said the guess is going to be correct if it's in the dictionary. Well, it needs to have a little bit more than that to be correct. It should somehow be related to the letters that were shown to us, right? This looks like the answer should be pigs. That's probably also correct. But it accepted hurt because hurt is in the dictionary, even though it doesn't use any of the letters that we were given. Okay? So the conditions for being a correct guess, they're a little bit more intricate than just the thing appearing in the dictionary. So we have to figure out if the letters that the user gave us, if those are also, or the letters that we gave the user, if those are the ones that are in their answer. So how do we do that? Yep. Well, that was actually our first approach, was that instead of checking if guess is in words, we would check if guess is equal to W, the word that the computer picked. But we thought that wasn't really fair either, because of words like tease and seat and eats, all of those things, the same set of letters, or the same collection of letters, or same bag of letters, if you like. They make all of those words. How's the user supposed to know which one we picked? So that didn't seem fair either. So on one side, we were being too strict with a correct answer, and on the other side, we were being way too loose with what's a correct answer. So certainly we would like the guess to be in the list of words, so in our dictionary. But we want some other condition as well. So what I've got is there's this array, WS, which contains all of the letters that I show to the user. And then there's this string guess, which is the thing that the user gave us. Can anyone think of a way to check if the letters in that array are sort of match up one for one with the letters in the word the user gave us? What's that? Can we use... well, we can't just ask if they're equal, because the ones that we show the user are in some order, and that's not the same order as the ones in the user's word. So, turns out this is not so easy, right? I mean, we could do it, but, or at least on the surface it doesn't seem easy, because, well, think about what you'd have to do here. I can't just look at the letters the user used one at a time and check to see if those all exist in the word or in the list that I gave to the user, because, well, maybe the user might have used the letter P twice, but it only appears once in that first list. That's not a correct answer either. So there's, or maybe the user made a word that's shorter. Like, for example, here, maybe the user would enter the word pig and not use the letter S. Then the sort of obvious check, we could check P is in the list of letters he was allowed to use, I was in the list of letters, G was in the list of letters, all looks good, but we didn't check that they actually used the letter S. So it looks like there's some complicated conditions to check, but actually there's a trick that, it looks like just a cute trick, but actually it's a very fundamental thing we do in computing, and it's called putting things into a canonical form. So we have two things. We have the word that we picked from the dictionary, and we have the word that the user entered. And what we'd like to say is those two things are good or acceptable if one of them is just a rearrangement of the letters of the other one. So rather than try and rearrange one into the other one, what we're going to do is pick one standard form for a collection of letters. And it's called a canonical form, so that both of these things, if indeed one is a rearrangement of the other, they should both have the same canonical form. And the canonical form that's really natural to use here is just to take the letters and sort them. Just sort them alphabetically. Then, if this one used all of the same letters as this one, and the same amounts of letters and everything, then when we sort this one alphabetically, we get a list that contains those letters in sorted order. We sort this one alphabetically, we get a list that contains letters in sorted order. And if those two lists contain exactly the same letters in exactly the same order, then that means that the letters here were a rearrangement of the letters here. So let's just check that. Okay, so for example, IGPS, that's what was presented there. So that's a string. And in Python, at some point when I was showing you lists, we saw that there's this function called sorted, which will sort the elements of a list. In fact, it'll sort the elements of any sequence, including a string, and give you a list of these things in sorted order. So if I sort IGPS, then I get back a list which contains GIPS. So there's another string, pigs. And if I sort pigs, I get back a list that contains the letters GIPS in that order. And look at this. Those two things are equal. So it doesn't matter what order I have on the left-hand side in the word pigs and what order I have on the right-hand side, the letters IGPS. Once I sort them, if they're using all the same letters in the same quantities, then those two things will be equal. And that's because I'm basically taking each of those things and converting it to its canonical form, which is the same set of letters but in sorted order. Okay. This is looks like an easy trick here, and it is, but it's also a very powerful technique that we use in computer science and in a lot of things for somehow identifying things as being equal or belonging to the same category when on the surface they look very different. We take those two things that look very different, we reduce them to their same canonical form, and then check if the canonical forms are exactly the same. So we distill them down to the important part that we care about. And in this case, sorting them is enough to do that. So I don't need to know if guess is in words even. All I want to know is if when I sort the guess, if that's the same thing I get if I sort the original word. Okay, what's this word? Hide. All right. This word? Hens. All right. So let's try good. That tells us it's wrong, as it should. Yes? Good question. Let's try. That tells us it's right, but that's not really a word, is it? So we actually want both of those things. Is it the same set of letters, the same quantities, and is the guess in the dictionary? Now, if I say marrow, tells me that that's wrong because it's not a word, even though it's the same set of letters. Clef is actually a word already. Shed. So this finally seems to be working. Yes? No. Sorted returns a new list, which is whatever was in that sequence you gave it in sorted order. Okay. So it didn't modify the sequence I gave it. In fact, in Python, you can't modify strings. You can reassign the variables. I could assign guess to be a new string, but that original string, whatever it was, it can't be changed once it's made. Okay, good. All right, so we seem to have some. So let's write something a little better here. Correct. That's a word, all right. Let's just say correct, because it's more than just a word. It's really a correct answer, one we're willing to accept. And the point is to make this into a game. So we have some nice functionality here. Let's wrap it up into a function that's usable somewhere. So let's say def ask a question. And so it'll be a function that takes a list of words as an argument, and it picks one at random, shuffles it, and then presents it to the user. Okay. All right. And once you start writing something that's sort of a real application that's becoming a little bit less trivial, it's helpful to break things up maybe into little bite-sized functions and actually almost do everything inside functions. And so in the end, your application is basically a one-line program that just calls a function. So I'm going to make a function called play game. Doesn't take any arguments. And my actual program is just down here, just calls play game. Okay. Let's just see that still works. Okay, so that seems to be working. Now, it's not really much of a game yet because it only asks one question. What's the next feature we could add to this game? What do games typically have? A timer? We can do a timer. Eventually, it's not what I want to do right now because it's not such a clean or nice looking thing. Yeah? Okay. So, so we should think about how we envision this game, or at least, I mean, we can explore the state space, but we might think the game consists of asking these things one after the other, and then we stop, let's say the first time they get one wrong, something like that. Okay, so that sounds like a while loop. So we'll make a counter that keeps track of how many wrong answers they've entered. It asks a question. And now we need to know whether they got that right or whether they got that wrong. And our ask question function wasn't really designed for that, so we should rethink what it should do. And maybe it should return some useful information. For example, maybe if you got it correct, then you can return 0. And if you got it wrong, you can return 1. Okay. Let's put a comment telling what this does. Okay. And so now we can say something like, so if they got a right answer, because it returned 0, then, well, maybe we should also keep track of the correct answers. So initially they start with 0 correct answers, 0 wrong answers, and as long as they have no wrong answers, we ask a question. If they get it right, we increase the number of correct answers. If they get it wrong, we increase the number of wrong answers. Okay? And maybe at the end of the game we can print their score, and the score is just the number of correct answers. Okay, what's this one? Waxy, good one. This one? What is it? Aged, good one. Even four-letter ones tend to be difficult. Game over. Wrong answer. I got 2 correct and 1 wrong. So we can rethink about, different design choices about whether we should quit after the first incorrect answer, whether we should give them 3 incorrect answers, or maybe if they get, a couple incorrect in a row or something. We can think about the playability of the game, and that's the kind of thing that you experiment with. So that's, one version of the game. What other features could we add to this? Yep. We could increase the length of the word at each level. Aha. That's a good idea. Yes, just for the testing we've been doing here, in fact, we wrote it here, we limited ourselves to 4-letter words. And the reason is not because we wanted to see bad words, but just because beyond 4 letters it starts to get difficult. In fact, we looked at some sample of words in this dictionary, and they get, on average, they're pretty long. Typically, even 8 letters is not uncommon, and those things become harder. So maybe we can use that in the design of this game to make some kind of progression. So as you get further and further along, you get better, and you get longer and longer words. Okay, so that means that instead of taking our list that we have and just getting rid of all the words that don't have length 4, we would instead maybe like to split it into a bunch of different lists with increasing lengths. Okay. So how would we do that? So I would like a list of words of length 4, a list of words of length 5, a list of words of length 6, length 7, length 8, 9, 10, and so on. How would I do that? Yeah?
You could have like a variable called round, and starting at 7,
Mm-hmm.
let the end of each level, you implement it, and you'll implement the length.
Okay. All right. Now, it really doesn't matter so much maybe in this game. Well, let's do it that way. So let's say at this point, original words is equal to words. So the first thing we did was we filtered out a bunch of problematic things with semicolons in them, words that were only one or two letters, words that started with uppercase or that had uppercase letters in them because they were sometimes weird. And that was our original, basically, at that point we had our original full dictionary. And then we made it smaller, only looking at the words of length 4. So let's save that original dictionary, and because we're going to need it later. We're going to need some of those longer words later. Okay. All right. So we'll start with, well, let's say that the difficulty is, we'll call that 4, meaning that we're interested in only the words of length 4 for now. All right, so let's just check that that continues to work. Okay, still seems to work. We didn't break anything. So when should we increase the difficulty? Yep. So should we do it? Let's try. Every time they get a correct answer, we should increase the difficulty. So when you increase the number of correct answers, so they just answered correctly, we'll say the difficulty is equal to the difficulty plus 1. And then we need a new list of words. And where are we going to get that from? Oops. We're going to get that by refiltering our original words based on difficulty, which has just increased. Let's see how far we can get. What's this one? Reds. This one? I see two N's there. Known. This one? I'm not seeing it. Anybody else seeing it? Teeing? Like so? We have a golfer in the audience. This one? Spheres. Correct. This one? What? Striking? Stroking. Man, this dictionary. This one? I'm at a loss. Goat beard? Wrong. Not in the dictionary. Or it doesn't match the letters. I don't know. One or the other. Okay. So, any observations about that particular, this version of the game so far? Yeah.
The difficulty kind of scales too quickly.
It kind of ramps up really fast. So how can we slow that down? Yep. Yeah, maybe every 3 you get right, it increases. So, so how would we write that? Yep.
A for loop?
It's the for loop is a bit tricky because if I do a for loop from 1 to 3, then what if you get some wrong in there? Then those don't count, and yeah. You can put an if statement inside of the if statement. What would that if statement say? Yeah. Okay, and if correct is equal to 6, and if correct is equal to 9, and if correct is equal to... So, anytime you have, let's say, a collection of if statements that could, for example, be replaced with a formula, typically it's better to use the formula. Yeah.
We just do 0 point, like 3 repeating for a long time, and then change one of the longer digits to 4, so that they wouldn't overlap until we have the entire point.
Is there an easier way to wrap that up? So our difficulty starts at 4, and every time you get 3 right, it should go up by 1. So for every 3 correct answers, it should increase by 1. Is there a formula that we can use for that? Yep. Yep. So the difficulty is at least 4 plus the number of correct answers divided by 3. And I need the difficulty to be an integer, so I use integer division. Then if the number of correct answers is 1, then the difficulty will be 4 plus 0. If the number of correct answers is 2, the difficulty will be 4 plus 0. If the number of correct answers is 3, the difficulty will be 4 plus 1. Exactly what we want. If the difficulty, as soon as the difficulty is 6, it'll become 4 plus 2. As soon as the number of correct is 6, it'll become 4 plus 2, and so on. Okay, so let's see if that's more playable. So let's go fast here. Him. Taught. Anyone know this one? So we'll pause for 1 second. First three questions were 4 letters. Next question was 5 letters, just like we wanted. So we're not only playing, but we're testing here. It's a nice thing about making games is the testing is fun, unlike doing other things like in the first assignments. What's this one? I don't see it. It's lock. Games. We're up another level of difficulty. Potash. So we have a golfer and a bomb maker in the audience. Yeah. Regale? Does that work? No. What is it? Gla. Oh, lager. I guess it doesn't think that that's a word. It is, of course, limited by the words.text. Yeah, lager is not in the dictionary. Don't know what that was supposed to be. Okay. Good. Now finally, what else can we do to somehow improve this game a little? Yeah. That might be nice. Like, for instance, it would have been nice just now, because I still don't know what the answer is for that. So if you got it wrong, one correct answer was we'll show at least one of the correct answers. You got 0 correct. The correct answer was Veer. Okay. So it gives us this information now. Anything else? Yeah. Yeah, that's a good option. So let's wrap that in its own function. Let's call that application. Oh, I shouldn't call it. Continue is a special word in Python, so don't make variables called continue. Call it another. Would you like to play again? And then while another let's be really generous. Whatever the user enters, we'll convert it to lowercase, and as long as it starts with a Y, we will play again. So we play game, and then we ask our question again. Okay. And now our program calls application. All right, good. Now there's lots of things you can do to make, to improve things here. For example, one thing that seems to, that maybe you noticed, maybe you didn't, there's a kind of real abruptness to this game. It ends abruptly, it gives you, it congratulates you and asks you the next question and so on. And sometimes actually dramatic pauses help improve things. So, you just enter a correct answer and, it shouts correct at you and then asks you another one instantly. So you might like to just insert a little pause there so you can bask in the glow of your correct answer and the congratulations that you got from the computer telling you that you're correct and how smart you are. So we can we should maybe do that. And so let's see. We refer to our friend the internet. And usually in these programming languages, pauses like that are from some function called sleep or delay or something. And indeed, in Python, there is a sleep. In the Python time module, there's a sleep method. You tell it the number of seconds that it should sleep for, and it just inserts a pause before executing the next line. Okay? So let's insert some appropriate dramatic pauses here. All right, and we can really and since we're using a function in the time module, we need to import it. So let's see if that... All right, welcome to Word Scramble. Get ready to play in 3, 2, 1. There, isn't that more exciting? Okay, so now we see that we did this wrong, right? You shouldn't be welcome to the game every time you play. So we put our, we put this code in the wrong place. We put it in the place where you're asking a question, when in fact, we only want that at the beginning of the game. Play the game, maybe after the dictionary is loaded, well, wherever you want. Now, in real games, this kind of thing is often used to hide things that are happening behind the scenes. So you won't come across it in this course because the games will be so simple, but often these kinds of splash screens and in welcome screens, they're just there to hide the fact that your game console or your computer is loading a whole bunch of resources off of a disk or off of a network, and that takes some time, and it's just kind of keeping you entertained in the meantime. But it also does provide some drama. Okay, so we have this sort of intro splash screen, and maybe we should also, after somebody gets the correct answer, give them 2 seconds to enjoy the fact that they got their correct answer. And maybe we'll put a blank line just to... Okay, welcome to Word Scramble. Anybody know what this is? Cups. Wrong. Okay, and so I think that's starting to feel a bit better, feel a bit more polished. Again, the game over was a little too abrupt. There's a sort of couple reasons for that. One is, again, there was no delay. So maybe even after you get a wrong answer, you should give them a couple of seconds to reflect on how dumb they are for getting a wrong answer before telling them the game is over. And yeah, so there's something maybe a little bit better. You can play with that to make it as nice as you like. The other thing that's maybe a bit abrupt is maybe one wrong answer is actually a little too harsh. You should let them get 3 wrong answers. So maybe do something like, well, wrong is less than 3. And when they get a wrong answer, something like this. Here's one that would be really hard for me because I don't know how to input that letter. Maybe I could cut and paste it. Let's put the wrong thing. So there's a nice pause. It's wrong. It tells you how many lives you have remaining. And now things seem to be working better. So you can very quickly get to a point where you start obsessing over this and really working out the fine details of it. But like I'm doing right now. But yeah, you see you can get to something reasonable. Is there any other feature we might add to this to really ratchet up the tension? Yeah. You could do that, but I guess if you're any good at it, you quickly ramp up to the difficulty you want. Somebody mentioned at the beginning, but I thought it was a bit too early to move on with it, but maybe have a time limit on the time it takes for a correct answer. Now, for these text games like this, there's a few ways to do that. Unfortunately, there's no way that is simultaneously really nice looking and that works on every platform. There are ways, there's a couple of clean methods that will work under Linux and Mac OS, but will kill Windows, and then there's a method that will work under Windows, but won't work on the other OSs, and then there's like still other OSs outside of those. So rather than have something that's nice, but doesn't work on all platforms, I'll choose something that's not nice, but at least works on all platforms. And if you go to the course webpage and look at the assignment, you'll find a snippet of code that's available for doing this kind of thing if you need to do it in your game. So it's kind of simple. In fact, it uses the time module again, and it's not quite as nice as we'd like. It basically asks for an input, says you have this much time to enter it, and after that amount of time, nothing happens. So it still waits for you to input something and press enter, but once you do that, it measures how much time has elapsed and then decides whether or not to accept your input. So it's not perfect. I would rather have something that after the time has elapsed, it basically doesn't accept your input. Or even better would be something with a counter that counts down, shows you how much time you have left. There's just not a really nice, clean, cross-platform way to do that. And later in this course, we'll be making much more interesting games than text games, real graphic games with, using Pygame. So then you'll be able to do as many fancy things as you want, rather than deal with writing a bunch of code for text games that's trying to be cross-platform. But for now, let's just take that function and use it. So we have something called timed input that looks just like input. It takes a prompt and a timeout value, and it gives the user that much time to enter something. If the user enters something in time, great, it returns it. And if the user doesn't, then it returns just an empty string. Okay, so, and instead of input, we'll use timed input. And what do you think is a reasonable amount of time? 5 seconds? 10 seconds? Number of seconds equal to the length of the word? Let's try that. I have no idea. Okay. Do you guys have your thinking caps on? Are you ready? Because we're under the gun here. We only have 4 seconds for each of the first ones. I missed a closing parenthesis. Yeah. That was a real disappointment. 3, okay, this will count down for us. 3, 2, 1. Time out. In French, unit, of course. Near. Game over. So it needs a little bit of work in terms of timing. It looks a little too hard. Maybe something more like 2 times the length of the word is a more reasonable thing. Let's give that a quick test. Good. What? Nobody wants to tell me what this is? The 8 seconds is up now regardless, so it doesn't matter even if we get it. Ague. We have a doctor in the house. Whew. This can't be difficult. Any idea? Pop up? Well, I don't. Papa, of course. All right. We're doing well. Getting harder now. Any ideas? I suspect that our 12 seconds is up by now. Bassos. Okay, 6 correct answers, 3 wrong answers. Not bad. And again, more dramatic pause, game over, print this, and back here in our location. Before we ask them if they want to play another game, maybe we should give them a couple of seconds to absorb the outcome from the previous game. Okay. So there you go. In the space of, that was roughly, for this one game, it was roughly one class. We came up with a game that seems to satisfy, all the things that a game should, right? It requires some skill on the part of the user. It has some idea of scoring, so you can know how well you did. Yep. Yep, that's the next feature you could add, how many players. What I find about these text games is 2-player things tend to be not so playable because they keep having to push each other out of the way to get to the keyboard. With something like Pygame, actually, Pygame does support controller input, so if you actually have the right setup, you can make a real 2-player game with 2 controllers. But I wouldn't go too far that way with these text games, unless it's going to be some networked game where 2 players with 2 different computers get to use it. Yep. Yeah, so that's the problem. I can make it so that works, and it'll work on this computer, and it'll probably work on any Mac OS machine, but then somebody with a Windows machine it's not going to work for. So there's not a really nice cross-platform way to do that with these console-based text games in Python. And it's kind of, even the way to do it that works on this machine is still kind of hacky. It's using some really underlying system stuff that I certainly wouldn't explain. We could use it blindly without knowing how it works, but it's not really the point. But I agree, it really takes something away from it when you know the counter is counting down and at some point it's expired, but you're not really sure yet. So it would be nice, but it's not feasible right now. Later in the course. Okay, so we happy with this game? Should we put it to bed? Okay, good. So then what I'll start now, sort of multiple choice quiz questions. So let's take a look at the file, what's in there. Okay, all right, so it kind of looks like questions. And it helps if we make things wide enough to see. So what I see here are, looks like a question, and then a list of, looks like potential answers, right? What's the main solid ingredient of alphabet soup? Pasta, rice, potato, egg. And then there's another thing here. I don't think food and drink is an answer. I think it's a category. And then there's a number. Any guess what the number is? I would have thought that too. And at first I did think that. But then I looked a little longer and realized, well, there's some counterexamples here. So let's see. The name of which island is also an orange liqueur? Curacao, which oddly is blue in color. But that there's no interpretation of that I could see where Curacao is the answer number 2. So it turns out actually that last number is supposed to be the level of difficulty of the question. Okay, so that'll be something we can use later, but not so important now. So it looks like the format is question, 4 answers. No, not 4 answers. Portugal, Greece, France. I don't know why this is. Oh yeah, no, question, 4 answers, and category, and then a difficulty level. And it's hard to tell exactly from looking at it here, but it looks to me like things are sometimes lining up in some way, and that's because it's using tabs to separate things here. We can investigate that more carefully. So let's just fire up Python and say we'll open quiz.csv. We'll read it. We'll split it into lines, and that'll give us a list of all of the lines in this file. Let's look at the first line. And indeed, so what I see here, inspecting it in Python, is, yeah, there's the question, and there's a tab, that's the \t, and each answer is separated by a tab. So this is a CSV file, and the thing that delimits the columns of the file, so it's just like a spreadsheet. In fact, you could load this into any spreadsheet application. The thing that separates the columns is the tab character. Okay? And so that says, well, that means we should be able to do this. Tell it to split a line at T, and then we get back a list of that for that line that has exactly the things we want. Okay? Good? So a lot of times, depending on the kind of game that you're making, especially if it's a data-driven game, the first part of the development process is doing this kind of thing, looking at your data, seeing how it's formatted, how you're going to read it, and how you're going to organize it. So that's what happened even with something as simple as our word scramble game. We first had to grab the dictionary, get rid of some problematic entries, and then figure out, well, how is it that we can pick random things from there and scramble them and so on. So that's what we'll start today, dealing with these questions and this list of questions and getting them into a format that we can use so that when we come back, we can really ramp this up into a serious game. So let's call this one quiz game. And Python's a nice flexible language. We can just start by writing a simple program to load this thing and get what we want, and maybe display a question or two, just so we can have a rough skeleton. So we already had this. And so that gave us what we saw, a list containing one string for each line in the file, and then the lines in the file, we'd like to split those as well, and we split those using splitting on string.split on tab characters. So that's going to be q.split on tab character for every line q in questions. Okay. So let's just see that loads everything properly. question 0. There's the question, 4 possible answers, category, and the difficulty level. All right. Well, so let's think about features again. What's the sort of most basic functionality of a quiz game? Like sort of the first kind of thing we have to deal with. And the first thing we should do. If you had one feature, you should be able to do, yeah. Too soon. That's like a fancy feature in the future. Just like, if I want something that works by the end of this class and we can have fun with, yeah. Yeah. Pick a question and ask it. Okay? And even we'll see that that's not trivial. Okay, so we saw, we've done this before. When we have a list of things and we want to pick one at random, there is this random module that contains a function called choice that will pick exactly one element from a sequence. And so what we've got is a list of questions. Let's pick one of those. Okay. Test that. There you go. So that picked a question from there. Which singer was born Robert Zimmerman? Good answer. Did you know that? Okay. Good. We have a music fan in the audience. A Dylan fan, anyway. Who sang the Bond theme from Tomorrow Never Dies? That's actually a recent Bond. Recent-ish. Yeah. That's correct. Duchess is a cat in which film? Aristocats. Correct. Who released the best-selling album Monkey Business in 2005? Black Eyed Peas. Correct. How do I know these things are correct? So the reason I know that they're correct is there's nothing in the file that tells me what's correct, and by inspecting the file and looking for questions I know the answer to, I learned that actually the first answer is always correct. The first answer in the list. That's something we'll have to keep in mind, because unless we do something about that, it's going to become a very boring quiz game very quickly. But let's ignore that for now. Let's write a function that asks a question. Okay, so somebody gives you a question, Q. It has exactly this format. It's this list of things. The first thing is a question itself. So, well, category is 0, 1, 2, 3, 4, 5. Let's not even bother doing that. Okay, so first we'll print the category, then we'll print the question, which is the element at position 0. And then we should print the possible answers. And those are at positions 1, 2, 3, 4, and not 5. want to print some number so that these are multiple choice questions, so we need the user to be able to refer to them. We'll print the number of the possible choice and then the value. Okay. And maybe there was one last piece of information in here. There was a difficulty level, and that was at position 6. What's that? Probably missing lots of things. Where? Oh yeah, always. Yeah. Every time I use format inside a print statement, I do that. All right. In which city was the famous Whiskey A Go-Go Music Club? Indeed. Okay. So that asks the question. Now let's wait for the answer. I don't know. What should the prompt look like? Something like this. Okay, and we'll have to randomize the order they come in, but let's see if we can even get this working in the non-random order first. All right, so you read the answer, and then sort of the baby version is if answer equals 1, you say correct. Otherwise, say incorrect. All right, so I think the answer is 2. I was incorrect. I think the answer is 1, and I was correct. Okay? So the first thing we're going to have to do to make this thing interesting is to randomize these answers. So it won't take a user long to learn that the correct answer is always 1, independent of the question. So we'll have to figure out a way to shuffle these answers. Can anybody give me a very quick way of doing it? Well, I'll show you very quickly one way of doing it, and then you'll have to understand why it works. So you'll have to figure out why it works before next class, or we'll cover it next class. So let's say term is equal to a list range 1 through 5. I make a list of the integers 1 through 4, and I say random.shuffle that thing. Let's make that before we print out the questions. So this is not correct code anymore, so let's just Who had an instrumental hit with Midnight in Moscow? Now I don't know the answer because they've actually been randomly shuffled. Good question. So that's because I now iterated through the range of 4, which is 0 through 4. So let me just fix the way that that's printed. That's printed a bit better. Which one is the answer? I have no idea. But just for your, or just for our edification, and maybe to help you guys understand what's happening here. Okay, so this is the line to focus on. What is this thing? Well, this is this thing that I created, which was a list containing the integers 1, 2, 3, and 4 that was then shuffled randomly. So that gives me this 3, 4, 2, 1. And from that, I can deduce actually that the correct answer here is Peter Pan. Anybody see how I deduced that? Yep. Yeah. Yeah. So in the question, the elements are stored at positions 1, 2, 3, and 4. 1 is the correct one. But when I print them, I actually print them first the third one, then the fourth one, then the second one, then the 1th one. And that's where the correct answer happened to be. So it happened to show up in the last place here. So next class we'll figure out how to figure out if they guessed the correct answer.